Okay, what about higher polynomials? Something like this. We're given that g of z is 2z cubed minus 4z squared minus 5z minus 3. We're told 3 is a root, so how are we going to solve it? Well, what we're going to do is polynomial long division. If z is a root, 3 is a root, then z minus 3 is a factor. So that's our factor theorem. Now what we're going to do is we're simply going to plug that in and solve. So, first let's put z minus 3 on the outside, and then 2z cubed minus 4z squared minus 5z minus 3. Okay? How many times do we need to multiply this to get 2z? 2z squared times. Let's multiply 2z squared, so we got 2z cubed minus 6z squared, and what we're left with is a 2z squared minus 5z. How many times do we need to multiply this to get this? 2z times, so this is going to be plus 2z. And what we're left with is 2z squared minus 6z. And then what we're left with is z minus 3, which is just once. And we're left with 0. Perfect. Now, how are we going to solve this polynomial to find the other roots? Z is going to be minus 2 plus minus the square root of 2 squared minus 4 times 2 times 1, all divided by 2 times 2, which is the same as minus a half plus minus the square root of 4 times 2 is 8, so that's just going to be minus 4. So it's going to be minus a half plus minus 2i. And those are your two solutions, okay? All we're doing is we're doing polynomial long division to find the other complex numbers. Does this video make sense? Well, you can subscribe so you never miss a video like it from me. Now let's get on with this video. Given that 3 plus I is a root of this quartic, how are we going to solve this equation? Aha! Now it's going to be a bit more challenging. The first thing we need to do is we need to work out what the conjugate of the other root is. So, this is going to be 3 plus I, which means z conjugate is going to be 3 minus I, okay? Now what we need to do is we need to work out the quadratic that has these two roots. To do that, z minus 3 plus I times z minus 3 minus I is going to be equal to 0. So therefore, z squared minus 3, minus z, I'm going to actually just rub that out, minus z times 3 minus I minus z times 3 plus I plus 3 minus I, 3 plus I. And that's all equal to 0, which means that z squared minus 6z, that looks like plus 10, that's equal to 0. So that is our polynomial, okay? Which is also a factor of this. Yeah? So now let's divide one from the other. Do it on this side. So first let's put z squared minus 6z plus 10 outside of the brackets. And let's put 2, oh god, that's a lot. 2z to the 4 minus 3z cubed minus 39z squared plus 120 minus 50. Perfect. How many times do we need to multiply this to get z to the 4? 2z squared times. So let's times 2z squared by all of this. 2z to the 4 minus, that'll be 12z cubed minus 20z squared. Sorry, I meant plus 20 there. And then so what we need to do is just subtract. So this is 9z cubed. And then this is plus 59. Yeah. And then plus 120. Perfect. How many times do we need to multiply this to get minus 9? Sorry, just 9. It's going to be 9z. So times everything by 9. Get 9z squared minus 54. Sorry, this is minus 54. Yeah. Minus 59, minus 54. Okay, cool. Z plus 90. So what we're left with is 5z. This is cubed, sorry. 5z squared plus 30z and minus 50. And lo and behold, we need to multiply everything by minus 5 to get, sorry, this is minus 5, Jesus. You multiply everything by minus 5 to get the last row as well. So it was 0. Now what we need to do is solve this one. 2z squared plus 9z minus 5. Z is equal to minus 9 plus minus the square root of 81 minus 4 times 2 times minus 5 all over 2a, 2 times 2. And if we plug that into our calculators, we should get an answer of a half and minus 5. And those are your two real solutions of this polynomial. Thank you guys for watching. If it doesn't make sense to you, do join my Discord server and I can answer whatever questions you have. And if you want to pass your exams with flying colours, drop me an email so we can get tutored. Keep on learning as you have no idea what you're capable of doing.